In this video, I'm going to go over adding vectors when they are not parallel or perpendicular. Any vector that you have that is not just horizontal or just vertical needs to be broken down first, meaning I don't have to break this one down because it only has a horizontal component. It only goes to the left. If it went up at all or down at all, then I would have to also break that one down. But this one is just horizontal, so I do not have to break that down into the two components. This one, on the other hand, okay, it's a diagonal one. It's not just up and down or just left and right. So I need to break this down into the pieces, the vertical and horizontal pieces, okay? This is tension, so I'm going to be using capital T for that. This 85 pounds, that's along here, so that's the magnitude of the resultant, and this 30 degrees is here, okay, because it's 30 degrees above the horizontal, so that's going to be this angle here. I'll use that 30 degrees and this 85-pound magnitude to calculate the horizontal and vertical components. First, I'll do horizontal. Then check and make sure you are using the correct thing if it's sine or cosine. I know that it's always times the magnitude, so 85 pounds times, then I need to see if it's sine or cosine. This is TX. This is the horizontal component that I'm trying to find first. And so that is the side that is touching or adjacent to this 30-degree angle. So I need to use cosine. Remember, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So for this one, because I'm trying to find the horizontal component, this is the adjacent, so I'm going to use cosine of my angle, which is 30 degrees. Okay, then when I put this in the calculator, 85 times cosine 30, it's going to give me this tension here. If you know the rules for 30, 60, 90 degrees, then obviously you can do that for this one, but I'm going to show you in the calculator because it won't always be a special right triangle. So 85 times cosine 30. Okay, if it gives you something like this, remember you can hit the button above enter and it'll change it to a decimal for you. I'm going to leave a couple decimal places here because I'm not going to round until the very end to get the correct sig fig. So I'm going to say 73.61. And whatever the unit is for your resultant, that's what the unit is for each of these components. So this is going to be pounds. Then, since I know I used cosine for the horizontal component, when I'm figuring out the vertical component, I know that it's going to be sine. Okay, if you want to double check that to make sure that you didn't maybe mess up on this one, then look at your diagram again. This is the vertical component that I'm trying to find. It is across from this 30-degree angle, or on the opposite side, and I know that sine is opposite over hypotenuse. Now I'll put that in the calculator. 85 times sine 30, and that is 42.5 pounds. Okay, I don't have to break this one down. I broke this one down already. I'm gonna go ahead and put these units here just so that we can see. So the X component, that was this piece, is 73.61 pounds, and then the vertical was 42.5 pounds. Sometimes it helps just to visualize that so you can see exactly where these numbers are going. The tricky part with this one is because this vector is going this way, it's going to the right, so this is pulling to the right, and it's going up, so this vector is up. When you are done with breaking down everything that you need to break down, then you need to figure out your delta X and your delta Y. For this one, delta X, I have two components here, 54 pounds this way, 73.6 pounds this way. because they are going in opposite directions, okay, they're parallel, so they can be added mathematically. However, they're in opposite directions, so they're going to end up being subtracted. 73.61 pounds minus 54 pounds. Put that in the calculator. So delta X is 19.61 pounds. Now, delta Y, I didn't have a vertical component for this at all. I just had this vertical component for this vector. So the only change in Y that I have, or the only Y force, is 42.5 pounds. Okay, so now I know the resultant's X component and Y component. This is for the entire resultant with these two vectors taken into account. If you need to redraw that, I suggest that you do it, because that will help you figure out in a minute what fraction you need to have set up for your tangent. Okay, these are going to go into your Pythagorean theorem, and it doesn't matter which one's A and which one's B, but in a second it will matter which one is used on top or bottom of tangent. This X component here, I need to see which direction it's going so that I know how to draw it. It was 54 to the left and 73 to the right. So this leftover, this difference, the 19.61 pounds, that's to the right. So say this is my hook, sorry, here. Then I have 19.61 pounds to the right. And then my vertical is 42.5. Okay, I suggest that whenever you are looking at your resultant and you have the X and Y components, draw the horizontal one first, because now this is my resultant. I can find this magnitude by using a squared plus b squared equals c squared. But also, the angle that you typically want to find is the angle above the horizontal, or the angle north of east or south of east. So maybe you're going below horizontal. But if you always put this horizontal vector first, then you'll always be finding the correct angle. This is theta. I'll do another video explaining another one for tomorrow. So now I can do a squared plus b squared equals c squared. Oops. Again, it doesn't matter which one's A and which one's B. 19.61 squared plus 42.5 squared equals c squared. Okay, and then you're going to end up taking the square root of that. I'm going to put this whole thing in the calculator to get c by itself. So square root of 19.61 squared plus 42.5 squared. 46.8. How many sig figs? Okay, I need to round to a whole number because I got 2 sig figs. So 47 pounds. Now tangent. Okay, to find theta, it's going to be the inverse tan. Tangent is opposite over adjacent. Okay, so for this one, here's my angle. This is the angle I'm trying to find. Opposite is 42.5. And adjacent or touching or next to, the angle is 19.61. And angle, round to that to a whole number too, 65 degrees. Okay, to write this entire thing, this is talking about tensions, 2 tensions pulling, so we'll do capital T for tension. It is a vector. 47 pounds at your angle 65 degrees. And then here's the horizontal, and it's above that. So 65 degrees above the horizontal. Okay, and that's it for that one.